Hello everyone, my name is YF Pim from Parson Brinckerhoff, and today I'm discuss about a visualization method in FDS. It's called CAD and GE1. First, I will introduce a little bit what is that, and then how to prepare one GE1 file and what kind of benefit it can bring to the commercial projects, and some case studies and the conclusions. In Asians nowadays, there's a lot of new infrastructure or commercial project is under design or under constructions, and most of them have a large scales and they are not fully compatible with the local fire safety codes. Because of this, the fire engineer approach is needed. Usually, we need some numerical simulation to prove the performance, and FDS is usually the simulation tools for that because most of the local fire authority recognize FDS. For numerical simulation, there's a lot of party involved on it. We got the geometry models from architect, the fire safety strategy and fire protection design from the engineerings, and our clients and authorities and local fire department and city councilor may get to read or approve these simulations. Those general public, they got whole different viewpoint with the engineers. In engineers, we usually care about the boundary condition, the configuration of the mesh or the grid size, and the fire property, the tenable environment, such that. But for the general public, they still care the fire property and where is the fire location, and also the tenable environment. But they care the most of the time. They care the most is the geometry details. That's why, because right now in Asia, a lot of designs with another design approach called building information modeling (BIM), which means they're doing the 3D model from architect to the engineering designs. They integrate all the design into one models in 3D format, and also the 3D format include a lot of data in that. So the client's authority, they get used to read the 3D geometry, and they would like to see how good is the 3D model, basically. And because of the limitation for Cartesian grid, sometimes our model in FDS got steps on it. And also, we got some other CFD simulation from Fluence for proof the HVAC design or proof other things such as pressure transients. They also read the 3D models. The CAD and GE1, basically, according to the smoke wheel manual, is a geometry description file. It's GE1. Also, they call it dummy rendering files. It's basically a CAD model embedded to the FDS models, and you can build it in the smoke wheel. So it's totally independent with the FDS mesh. It's just the CAD model. So you can catch every geometry detail inside it. Basically, you can create anything inside it in there. It improved the realistic for the models. This is the examples. I don't know what happened here. In this example, we are doing some tunnel fire scenarios. This is the truck or bus on fire, and you can see in here, the bus is just a block. And there's other car waiting for it, and this got a local smoke extraction, and they have water suppression system on it. And with the CAD, we can do some more real models. For example, this is the truck and the cars, and you even can do the post-processing with these models. Prepare a CAD or GE1 file is not hard at all. First at all, you need to put the following sentence into the FDS input files. And then you need to create a 3D geometry models in 3D phases. You can do that in AutoCAD. And in fact, a lot of nowadays project, the architect already have the 3D models. You just need to convert it to 3D phases. And then input this CAD model into Parson and add the detail in it, such as the mesh, the exhaust supply, and the fire load. And then when you when you view it in smoke view, you probably see something like this. And then you can go to the show menu and get the CAD. You can get something exactly same with the AutoCAD files, AutoCAD models. This is for simple geometry. For really complex geometry project, first we get the models from architect for engineering. Some of them maybe in 3D, some engineering design still in 2D, but we can see this. This is a hub station I will talk about later. And this is the MEP design, the drawings. And we integrate all this information into an AutoCAD 3D model for doing FDS. Import this file to Parson. Actually, we prepared 2 models in Parson. One is actually with all the engineering data in there, such as the suitable mesh size, the fire load, and then exhaust supply, and also the other boundary conditions. The other one basically is just the geometry models. And you can refine it, and then export it, replace after you simulate it, you replace the GE1 file with the real engineer one, and then load it in the smoke view, and you can get, this is the one just with the FDS model, and this is the one with the GE1 models. You can see it looks much close to the reality with the CAD model in it. What kind of benefit it can bring to a commercial project? In commercial project, the most critical thing maybe is the delivery days, especially in Asia. The client try to ask you finish the simulation as soon as possible. And the most important is communication. If you got a right 3D models, it helps a lot with the communication. You don't need to explain why I did not catch the architectural features. And we can avoid over detail the models. You know, in our simulation, all this conference is talking about you need to use the equation in the manual, choose the right grid size. And then we use the right grid size. We don't need to conduct a super refined grid to capturing maybe some features. And also, sometimes it can avoid the rerun. For example, here, it's a road tunnel in Singapore. And from here, they have a slab over. After the maybe presentation to the client, they would like to change the color. The slab over, they would like to change the color scheme. If you have a GE1, you can change color scheme anytime. But if you're without it, you probably need to rerun it. And also, this is a case study. This is a large-scale hub station in Hong Kong. Right now, it just have 3 line hub stations, but it will expand to 4 lines, 3 local line and 1 intercity line. And our company role in this project is be a building service design. And in this scope, we need to drop the BIM model with it. You can see the BIM model. We have the architect, structure, and also the MEP, all the surface in there. And this is what the station look like right now. And in fact, this one is the one they will add, this platform. So whole station concourse need to be redesigned for the normal operations. So during that, they have a lot of phases during construction. So lots of simulation need to conduct. We conduct over almost 20 simulations for these stations. Most of them are for concourse, but some of them for the platforms. And the coverage for the concourse is huge. It's 160 times 120 times 15. And we conduct the simulation with fire and also evacuations. For the FDS model in this case, this is the original FDS models. We have a refinement, a refined zone around the instance zone around the fire, but normally the grid size for other features is 0.4. But even you refine it to 0.2, which means 8 times the mesh size, it still won't catch the detail. Maybe close it. This is the model with the CAD and GE1 up on it. You can see now the column is circle and some column are rectangle. Before, everything is just rectangles. They have all the details. So for present this to our clients or present this to the architect, they will understand what are we doing. And if we got some modification to ask the architect, they will easily to do that. Also, I have the MEP, the air ducts on it, exhaust point. See, some column in this project is rectangle, but some of them are circles. The other case study is Intercity Express Rail in Hong Kong. This is the new station for the express rail from China to Hong Kong. And it has the largest multi-track underground platform and the fan area in Asia. There are a lot of track crossover around here. The model is kind of complicated. Our role is use the numerical simulation to prove the smoke control systems. And also, the total area is around this. Just only 8 cases we need to absorb. Why we need to use the CAD? Because CAD system. Because in this project, a lot of general public is really concerned about. It's a high-profile project in Hong Kong. The subway company need to have good presentation to show it to the city councillor in case there's something happens. This is the FDS models. You can see the train is stopped here. In this scenario, the train stopped here and the fire happens here. Similar with the previous one, we have a refinement around the instance zone. And the other area, the grid size is around 0.4. But you can see everything is, because of the grid size, the shape is like this. But with the CAD, the presentation is much nicer. The track is fully same with the architect design. In fact, all this kind of 3D model are ready. Most of architects, they design using 3D nowadays. Not like before, if I need to create another 3D, it takes a long time. Now, you just need to do some format conversions. These two are same model and same route. I just load the program, I load the CAD in it. And the conclusion is that GE1 actually is a really user-friendly function in SmokeView. It's really easy to get it. And the 3D, as I mentioned before, the architect 3D model is ready. And with the Parson, you can get GE1. Every scenario you generate by Parson, they already have the geometry models. And also, it can enhance the result visualization and improve the communication with the clients. And the most important is we can get the balance between the visualization, how many computer sources you want to spend on the visualization and the real simulation. As we mentioned, all the people mentioned before, we need to get the right grid size, not a super refined grid size. And to meet the, and I don't want to take like too long to do the simulations. And there's some way forward. It's like, I found out like the texture problem the texture can integrate in the CAD, but it's not fully integrated now. Sometimes the texture will be shifted. And also the obstruction hole, they can't display in the CAD. And the other one is the vent setting in FDS model and the CAD model, they are not fully matched. Today is my presentation.
Thank you very much. Do we have any questions? Start in the front.
I was just wondering, what kind of CAD files can you import into SmokeView? Is it just AutoCAD, DXF?
It's just AutoCAD, and remember, everything should be in 3D phases. That's it. And your AutoCAD, you can save as a DFX file. That's it.
Yeah, I'll interject there a little bit as a Pyrosim developer. Pyrosim can pull in DXF and AutoCAD files. The real enabler here is that SmokeView can read this GE1 format, which is, it's not really a standard format, but it's published in all the SmokeView information. So someone could theoretically write their own translator. It's just a list of triangles that are loaded by SmokeView.
Actually, this function, there's a free converter called DXF to FDS. But that one, if you convert some really complex geometry, it will get some unnecessary obstruction out. You need to take time to delete one by one. That takes really long times.
Just a question. Are you advocating that you're only showing to the client FDS simulations displayed on the CAD geometry, sort of falsely implying a higher level resolution you actually did the calculation at?
No, actually, it's like this. Before the simulation, we already tell everything, the grid size, everything to the clients. But when they presentation to the general public, such as the city councilor or some architect, they need to use this kind of presentation. If you show the
so they get the impression that the simulation is much more detailed and resolved than it really is.
The result, we're still using the FDS models to show it. We can use the CAD model to show it, but sometimes the result is on the mesh base, so you can see it's not. See, wait. Not this one. See, you can show something like this to the clients, but if you know FDS, you know this is impossible.
Yes, I guess that's my comment. I guess I have concerns when I see FDS simulations, on the left being displayed to people evaluating the results to make decisions on them with the geometry on the right, because most of the people you're showing these to don't know FDS. They don't understand the resolution you're running the calc at, and if all they see is the one on the right, they're going to falsely assume the level of detail of your calculation. And I think there's a danger in that. And that, it's one thing to show the geometry on the right. Here's the geometry so that you can have reference points and understand the design. But if you never show them the stuff on the left, then how do they really understand what it is that you've done in the calculation?
I understand. Usually we show it to the clients of the engineering team. We will show this to them. But sometimes they have some, I can't call layman, some boss, they would like to see this. If they saw this, they probably don't accept your simulation result. They said, the file should be on a bus, not a block.
Any other questions?
Not to sort of beat a dead horse, but I want to follow up on that, and just to say that sort of I think our opinion would be that when life safety issues are being addressed by anybody, we'd rather err on the side of them really understanding what is going on.
I guess I'd add a further opinion as another software guy that outside the fire community, there are other models that do similar things or that represent geometry at a less discretized level, but don't display it in the blocked way that FDS does. A sort of middle ground suggestion would be to make sure and display simulation grids if you're showing finer geometry, and that can at least sort of give an impression of the refinement of the solution in addition to the finer geometry. Thanks again.